Good morning, everybody, and happy holidays. And welcome to our webinar, 2025 Outlook, Advancing Visual AI with Landing AI, hosted by our very own Erica Gilbert. Erica, take it away.
Awesome. Thank you so much for that introduction, Adrian. We have a great agenda prepared for everyone today. So we will, as indicated, take a look at 2024 and all of the amazing features and capabilities, extensions to the platform that were released. We'll look at the 2025 near-term roadmap, in addition to spending a good, healthy amount of time in the platform to see demonstrations across those new updates. And then, of course, we'll leave time at the end to, foster any insights that we can gather, collaborate, and we really want hands-on engagement. So feel free to ask questions and make the most of the session. For the walkthrough today, we will actually look at the LandingLens platform. We'll take a look at the developments for LandingLens on Snowflake, and we'll also preview our capability called VisionAgent, which we'll dive into a little bit later. But there's just another overview of our agenda today. So just in reflection on 2024, we really feel we've revolutionized how AI-powered visual tasks can be incorporated by focusing on the user within the platform. So a lot of user-centric updates were provided. Those innovations empower users with more control and expand the versatility of how they're leveraging data sets. So you'll see this obviously in the demonstration, but we'll highlight the capabilities and showcase how they impact your practical workflows. So at a high level, here are some of the key capabilities that have been released throughout the year. You can also go to support.landing.ai and see the full set of releases. There's been quite a few, but we're just touching on some of the highlights here. And some of these are the more recent releases. So looking at the ability when training a model to end it at any time. This can be if you actually see the model performance improve. Perhaps you're running through 40 different learning cycles and your model performance is already optimized when you get to cycle 20. So to go ahead and stop that model. And then also in situations where sometimes the model might be stuck, this provides that fail-safe, but just that ability to manually end. And you'll see that when we go through the demonstration where there have been models that have been stopped before they were complete. In addition, we want to continue to extend the types of data that are incorporated into the platform. So we now provide TIFF support. It's a very common data type, particularly we see in medical fields working with this type of data. And actually the data we'll be using today is an X-ray use case looking at lung identification for pneumonia, normal, abnormal. In addition, we also have enhanced how data set snapshots can include more comprehensive information about the meta tags that you may be applying on upload. This can be very critical for an audit trail in which you can review how data sets were assembled when they were trained and what tags they're associated with. In addition, there's more granular ability to download model performance without associated ground truth. This can be great, and you'll see this in the demonstration as well, that you get predictions on unlabeled data for those use cases where you may be training a model and then running that model on a small set of data and then sort of moving on to your next project. This allows you to leverage that inference API, but not have to manually go through and just review each individual image in the platform. You have that CSV at your fingertips. In addition, we've also spent a lot of time updating for additional features, primarily focused around, as you'll see in our 2025 preview, extensibility and integration. But we also took a look at our UI, and again, with that user-centric focus, revamps how you can review the model performance. So I'll walk you through that as well in the demonstration. But from a API perspective, there's now a full RESTful API that allows you to perform all of the main tasks that you do within the UI today, such as train model, load data to specific projects, etc. And this allows our customers to create applications where the API is leveraged in systems where they're never going outside of the business ultimately. And of course, we want our customers to be able to move through the label process as efficiently but precisely as possible. So we have a label assist tool that was launched this year, which allows you to leverage the labels you've already provided and use predictions to accept and create improvements to existing ones. In addition, we also have updated how the models are made available through active projects. And now those models can be downloaded for offline deployment via our LandingEdge software or our Docker container approach. So just some of the capabilities. Again, you'll see many of these when we go through the walkthrough. And some smaller than other. Obviously, the full programmatic API compared to the model analysis. This is a UI adjustment, but still big impact in how you're able to evaluate and understand your models. A major release this year was mid-year. So in June, we joined the Snowflake marketplace. This was our initial beta launch in June. And the main benefit here is that you're able to work within an AI platform with a governed data ecosystem. So I'll demonstrate that synergy. It'll look very similar to the LandingLens platform you may already be familiar with, but it'll allow you to deploy those visual AI models directly within Snowflake while maintaining strict compliance and data privacy. That beta launch transitioned to general availability in November 2024, just last month. And we're very excited about the initial customer use cases making big impact, bringing visual AI into their workflows. Here's just an overview where you see the native app marketplace where there is now available LandingLens. So it's a straightforward install process that works within your Snowpark container services, all of the compute you've ultimately defined, and your full Snowflake account. So again, you get to keep your data and compute in Snowflake, but you're able to perform intelligence on top of that with all the existing tools in your Snowflake account, performing sort of analysis and able to really get big insights from the unstructured visual data that you have. In addition, we also had a major release this year. This was launched as an early access sort of party to developers primarily in October. And it marks a real significant advancement in developing and deploying. A lot of times we spend way more time in development rather than in deployment for visual AI application. You'll see this in the walkthrough today, but we've really designed this to accelerate the application building process through generative AI, state-of-the-art models, and intuitive tools. It's really exciting to see a prompt turn into a full application. Here you can see that in action, sort of you need existing images or video and the analysis happening in real time. But this is a visualization of that app builder. So you're able to take image and videos, those instruction-based prompts. VisionAgent intelligently pulls the right tools together to then generate actual code for rapid prototyping, but also production use depending on your particular use case. And you can see from VisionAgent perspective, There is the sort of plan and evaluate stage. When we go through the walkthrough, you'll see the level of detail that the agent itself is working to review. But it's leveraging, curated library from our, research teams of state-of-the-art vision language models. And it includes some zero to few shot models for object detection, counting, segmentation, visual question answering, activity recognition, and more. And then in the near term roadmap, you'll also be able to leverage your trained models that exist already in LandingLens. So there's the plan evaluate stage, but then of course, you actually have the agent assist in generating code. And then you can iterate that and see different versions of that code over time as you optimize for the task at hand. And then the ability to deploy either with a web API or Streamlit app, or your own sort of Python library. And then Landing is managing the AI infrastructure to host those models for cloud inference. So that's a big recap, a lot of huge items and some more minor but impactful coming through 2024. And as we look to 2025, we're going to continue to elevate how we scale our platform capabilities, focus on our security footprint, both in LandingLens as well as LandingLens on Snowflake, and integrate into other environments for seamless AI transformation. So here's a little detail on some of the roadmap that's coming in early 2025. So this our target delivery for this is Q1 next year. So likely late January, early February, but could bleed a little into March. Something that's been a common request among our enterprise customer base is the ability to leverage anomaly detection. So we will leverage the state-of-the-art that's available to focus really primarily not on the most performant anomaly detection model that's going to have the highest or lowest overkill rate, but rather will help businesses collect the data they need to build models to manage those anomalous processes, primarily when it comes to defect data capture. So helping you move to build defect models faster, or where defect anomalous data is scarce. We also will be updating and providing more granularity that sort of aligns with the data science standards with views of confusion matrix. This really helps simplify how you identify where there are error modes in your models, and will help improve overall decision making on next steps with your particular model. And then in addition, we also will be providing new ways to label data in the platform for particularly classification. So you'll be able to apply labels to many images at once. This is really critical because it helps streamline the workflow for efficient batch labeling that is accurate. The views in the platform make it very easy to see the data, especially for classification tasks. So it should be a big impact in your label data iteration process. But those are just some of the high level or early features that are coming. There are larger, what we call larger t-shirt size, so the large size t-shirt development efforts that are focused on where LandingLens can exist. So we will develop a containerized Kubernetes version of LandingLens. Part of the work that was done to port LandingLens to Snowflake informed how this will be provided in the future. And we have already been working with design partners to test this capability, and we'll be launching with those early next year. In addition, we'll also be focusing on how we can profile users with correct roles and capabilities to ensure workflows for data security, but also just management of how the platform is leveraged with credits, with model training. But all of this informs compliance for the enterprise. As we mentioned for the LandingLens platform, we developed the RESTful API this year that allows you to do all major functions like training and working with data sets, etc. But we'll have new third-party integrations coming that are really focused on interoperability to streamline the workflows across all sorts of different industries. So stay tuned for those new and exciting integrations. And we're going to continue to amplify how the Snowflake, the LandingLens on Snowflake application works. So there'll be updates on how the databases are managed from a table migration perspective to improve efficiency and operational performance. We'll also be adding additional API support so that in the same way that folks leverage LandingLens to perform items programmatically, you can do that as well with the Snowflake version. They'll be focused on histopathology applications that will extend the LandingLens capabilities also to healthcare and life science, where our initial focus and launch was primarily on manufacturing. So it's an exciting development year for 2025. Lots of good extensibility coming. So now we'll move to the portion of the webinar where we actually get into the platform. So you'll see three areas. So we'll work directly in our cloud LandingLens, where we'll look at the label assist capability I mentioned earlier. We'll review the model comparison reports, and then I'll also show you how you can download the predictions for data that you haven't yet labeled in the platform. Then we'll transition into Snowflake, where you can see the same capabilities you may be using already with one-click training. And then we'll step over to VisionAgent and work with a prompt associated to one of our use cases today. So here you can see I'm right in LandingLens. I'm within my particular demo organization here. 925 is that ID. Just calling that out because when we switch over to Snowflake, it won't be quite clear unless you're sort of referring to the containing application URL. So here I have a project for pill defect identification. You can see it's a relatively small set of data with 33 images. 14 of those have been labeled. Some of those have been associated with a labeling task, and many of them are also unlabeled. But as you know, with the platform, you need only just 10 examples to train your model. In this case, we're looking for scratches on these particular pills. And so what I can see based on that initial model, you can see this has been an update in the platform as well, where you can select from your different model versions and the confidence score associated or confidence threshold associated with that particular model. And from there, actually leverage the predictions to start labeling the data itself. So here I can see there are dotted lines outlining the scratches on this pill, whereas the one next to the unlabeled image has both a predictive and a ground truth label provided. So that's our pill number 27. But what I can do is actually click on the image here and see that there is an option to leverage the predictions. So obviously I can show or hide those here. But then I can click on the labeling assist. Will actually come through. And accept those that are in the task. Hold on. For example, I'm just going to hide the ground truth here and leverage the label assist to accept the prediction. And if there was suggestions, I would be able to hit accept here. So you can see how this might accelerate my labeling process overall with reliable, consistent predictions. And for example, you could adjust the threshold up or down to see more or less predictions depending on your particular use case. Sometimes it's helpful to have the predictions be a little more noisy, and then you can accept many of them or some of them, just depending. In this case, it's very simple, one single object detection box here. So that is the label assist capability. So now I'll transition to walk through all of the model comparison tools. So here, this will be the primary use case for the remainder of our session today. So we'll be looking at pneumonia diagnosis. Here we have 270 images, 170 roughly of normal, 100 roughly of pneumonia. You can see that these have been split for my different train sets into a distribution that makes sense. So that 70, 20, 10 split is available. We see that there are some models listed here on the side. So this particular project has had 3 different versions of models. You can see that this model here, it was not getting the performance needed. It was stuck sort of at a very low performance threshold. So I just manually ended that model. Again, it just allows you to sort of continue on and move through to your next ultimate task. And then we have a final model here that has both all 3 train, dev, and test sets set up. And we see information about the F1 score, what was misclassified, what is correct. This is an update from previous model metric views. You're able to actually try the model from this interface. You can download these metrics to perform your own analysis and generate a confusion matrix. But as mentioned, that will be soon available in the coming quarter. You can also drill down for many use cases. In this case, it might be more important to have to be less tolerant of false positives. So we'll focus more on the precision metric, or in some cases, recall might be more critical. Of course, you can look at the average here, but there's the ability to switch between those and see a presentation of the confusion matrix with the ground truth prediction and count right here at the top. But of course, you can view that full report to go into further detail and granularity. So here we see all of the data that was associated with the model when it was trained. We see this version had 172 train images, 49 dev, and 25 test. It was trained by me. You can see it was trained not that long ago. We see that this particular model has 29 million hyperparameters. So it was the beefier backbone that we have available in the platform. And it went through 40 different learning cycles. We did some rescaling that's higher than the standard associated with the platform. So typically for classification, you're looking at like 550 by 550. So this has a little bit more pixel on the image itself. And we've also done some augmentation. But we do see that loss chart coming down to 0, which is ultimately what we want for the model to be improving. But then we have the full performance report available here. And commonly what's really helpful is to look at your different test sets. So here we have an evaluation set that is completely separate and used on every single model version, and I'll show you that in a second as well. And we also have the test set that was randomly assigned by the platform itself when we performed our custom training selection. So here is where you can really drill in and start to identify what is incorrect And in this case, without a lot of medical background, it might be important for me to connect with my SME, my radiologist who really understands, and potentially correct the label. So maybe potentially this is pneumonia. And we can see the different confidence scores associated with these and drill in. We can see this is very confident that it's actually pneumonia. And then we could open that back into the build to perform any corrections that we might need. So this really is meant to be a guide to identify how to improve your model. Again, you're also able to download these metrics for yourself through a CSV. But of course, we get the overview here in a easy to read diagram of here we have the version 1, which was the default training option. So there was no test set held. So we see that 100% on training, 57% on dev. We ultimately want to move that needle up. And we were able to do that by the customized training options provided by going up to 67%. But then our golden test set of data performed lower. So we may want to drill into those 20 different images and potentially correct in the future. Other updates within the platform that are pretty critical for overall data management are all of the snapshots that you're able to create. So this can be on any custom set of view of data. So in this case, I could actually filter on images that have not been labeled and save this as a particular snapshot. But what I can also do is actually select all of these and download a CSV. So you can see in the view here, the model does not have a confirmation from the human subject matter expert, whether this is pneumonia or normal. So the model does not have the ground truth. But when I download the CSV, I will see, and I am confirming that I want it with my V3 model. So you could adjust and see all different versions that you have available and download that CSV. So when I open the CSV, you see obviously all the important information about the project and project type, the name itself, when it was uploaded. But importantly, you also see the predicted class. So you can do your own analysis and collate across a small or whatever set of data ultimately you want to get the predicted class and also the confidence score. And then we do provide the JSON as well associated with that. But this can be used in a lot of additional tasks and collate and provide some results that would be beneficial for other team members to see. But you can see the snapshot view here. There's the golden test set that I created. And then, of course, all of the generated snapshots every time the model is trained, whether that be a fast train or a custom train that I've performed. But you do get that overview. And if there's a model associated with it, you'll get the detail on the model itself as well. So a lot more flexibility with how you're able to get prediction results with the prediction CSV, and a lot of ability to drill in and really understand a model's performance and identify areas for improvement, ability to assign your own custom evaluation sets that are consistent across different model versions. And this really streamlines and creates a very clear model operation process for our customer base. So now I'll transition into Snowflake. And you can see it's on a new tab here, and I'm in my Snowflake environment. So you can see this is very different from how I'm accessing LandingLens. So the credentialing provided through Snowflake. But overall, this looks very similar to how you work and exist almost to exact parity within LandingLens, our cloud version today. So not all that different. Here we see I've loaded 20 images for our same use case here. And the options here are slightly different. So if I have data on a Snowflake stage, I'm able to port that over. Again, this ensures sort of consistent data handling standards. In this case, I loaded these directly from my laptop. So the same way customers primarily build models within LandingLens today is still accessible. And then I'm able to hit that one-click train button to work with my model. You can see I already did that here, and I'm getting 100% on the training set and 50% on the development set. So I do need to provide more data for this particular use case because we only have 20 different images here. But that same capability of snapshotting the data, provisioning for the GPU, doing the training and learning cycles, and calculating the performance happens exactly the same as it would in LandingLens, our cloud LandingLens, versus here within Snowflake. So a great option for customers who already have existing Snowflake data paradigms. Again, you can see that training configuration, the model used in this case, only 15 learning cycles, and also drill into the metrics the same way you just saw in LandingLens. So full simplicity, the same way the LandingLens today is meant to rapidly develop models. It is interesting to see in this particular use case, the heat map that's focused on where the pneumonia and normal might be. Many of the pneumonia areas are kind of hyper attention with the heat map in areas you might expect, whereas the normal is sort of more broad across the full lung. And we'd expect this to get more granular and fine-tuned into the features of what is normal versus abnormal for these x-rays as the model learns on more data. So now we've seen LandingLens on Snowflake. That was another major development effort as we went through 2024. And now we'll step to VisionAgent. So this is an interaction common probably to many individuals today. You are writing a prompt to help frame how the agent is going to perform ultimately a task for you. So it gives, obviously some information on how to describe the task and some examples here. You can even just leverage some of the example programs that are provided at the bottom. And you can also be specific on whether you want the agent to evaluate strategies and pick the optimal one, whether you want to try to do this in a very fast way, so in 1 minute, or with the set of state-of-the-art models. If you're aware that you're performing an OCR task and you want the model to leverage that, you can select for that with the customized tools. Now, because this does take a few minutes, I'm going to pull up the example that I already developed. So here, and this is actually not leveraging any fine-tuned customized LandingLens model, but you would be able to do this in the future. My prompt is to the agent to build an app to identify the X-ray data for pneumonia. And I'm instructing the agent to use a classifier and to identify normal and abnormal. And I want to actually create an interface that shows the result when loading the image and stores the result with the file name. The file name potentially is how I'm tying it to the X-rayed patient. And that is available in a downloadable CSV. And so you can see that the agent is starting to generate the vision code, in this case with a Python script. It's providing some context of what it's doing based on the prompt you've given it. And this includes sometimes encountering errors. You can also see the level of detail of the agent making observations. Here, obviously, it has loaded the data, that the sample image that I've provided for the context of the task, and gives you thoughts. In this case, the agent is saying, I understand that the user wants to build an app for pneumonia. I'll need to create a classifier, an interface, and store results. I'm going to start with generating the code for the classifier and then build the app around it. So you get the ability to see this level of detail should you choose. And then the agent will actually start to ask you questions. So when it initially was developing the Streamlit function, the Streamlit being the interface for the end application, and experienced an error. The agent asked me if it would like to proceed, and I said yes. And so it actually edited that Python file and created a Python script that performs the task ultimately that I asked. So it can process multiple X-ray images in a directory and save those results to a CSV file. And then I'm retesting this application with the X-ray image I provided in the initial prompt. And you can see the results of what that ultimately is. And then I actually am able to view the code for that, which is the process X-ray. So that would be for multiple. And then this is the classifier used. So we know that this is the underlying model that's applying the classification of pneumonia or not. And we also see the confidence score associated with that. And then I simply, once it gets to a state where I'm ready to leverage, I click a deploy button, and I can work with a web API to perform this task, or a simple Streamlit application to load the image and see the result. So now it's processing. And of course, sometimes you'll need to triage some errors here. But end to end here, I have, particularly with the web API, the capability to run this task multiple times on full sets of images. And this took minutes, not weeks or months to develop. So very exciting. I encourage all of you on the webinar to work with your own vision tasks. Again, this could be image or video. And this is part of our early access release that we will continue to optimize and make more enterprise ready. I do want to call everyone's attention. We went over quite a few big new features within the LandingLens platform, as well as our releases on Snowflake and VisionAgent. All of that information is available as part of our release notes that you can access with our support center. You can also subscribe to receive updates on this just by going to our website at landing.ai. And so with that, that is what I prepared to walk everyone through. So you can start to ask any questions.
Thank you, Erica, for a great presentation. And to our audience, thank you for these awesome questions. We look forward to answering them. Let's kick it off. First question. If I run this via an API call from my website, what is a reasonable expectation for cycle time from image sent to analysis and response time?
So with our web API, the typical response time is roughly 100 milliseconds. If you're leveraging our cloud API, we can update the queries per second to be more performant than that. But we'd highly encourage, just based on your use case, just having a quick consult so we can make sure that the right model type, the right image dimensions all of that's being leveraged for your particular project. And then for those that are running locally, it depends on the compute resources you have assigned. The VisionAgent can be a local only deployment, as well as our LandingEdge and Docker solutions. Hopefully that addresses the question.
Next question. How are we going to fine-tune the model to increase prediction?
So for LandingLens developed models, you're able to fine tune the model with additional data and labels. Just as you saw me work with this pneumonia diagnosis model today, there are 3 different versions. So the hope is this would continue to improve over time, especially as I leveraged subject matter experts that better understand the X-ray images at hand. What will soon be available in VisionAgent is the ability to leverage those same models that are part of your custom fine-tuned set of data in LandingLens. So that's coming in the near term. I believe February is the target.
Next question. I want to create models to judge some defects for some conduit. Are you able to help me create those models?
Yes, LandingLens would be a great tool to leverage building a defect model on conduits. Again, I recommend leveraging a consult so we can take a look and provide more prescriptive recommendations for your particular use case. But we work with a lot of enterprise grade clients who have production use cases that sound very similar to yours. And typically they're leveraging models that have been built on hundreds of images, not thousands. It depends on the data you have and how consistent it is, but those are some of the feasibility assessment questions we'll ask in that consult.
Great. Next one. When will we be able to leverage our domain-specific CV models that we created in the landing platform with this new VisionAgent?
So the target for that is February. So I would expect no later than end of March. So pretty near term within the next quarter's development cycle.
Excellent. Let's go to the next one. How does the manual training control improve user workflow compared to automated training?
So the goal with that is really just to provide flexibility to end the training at any point. This is beneficial if you've set a lot of custom training options and you're sort of experimenting what works, and you may see that the model performance is not improving, and so you just want to end that training. And it also, in some cases, can be beneficial as a fail-safe for when models get stuck.
Excellent. Next one. Can you provide specific examples of industries that have successfully utilized LandingLens on Snowflake?
So far, the industries that are adopting have been somewhat broad, but continue to reflect the types of customers we have on LandingLens Cloud. So healthcare, manufacturing, and retail. Healthcare, for example, with histopathology, data analysis, manufacturers performing defect identification. And again, that's beneficial within Snowflake because there's that robust data governance framework. But what's really adding a lot of value for those Snowflake customers is that they can work with the existing Snowflake tools to perform analysis on top of the model results. For example, to see confidence trends on model predictions over time. This can be a signal for model drift, as an example, and inform potentially reassessing or retraining a model, as an example.
Excellent. Next, we have a few more questions and we can wrap it up. What measures does LandingAI take to ensure regulatory standard in Snowflake integrations?
Because we sit inside of the Snowflake environment, we are ensuring the compliance by leveraging those strong data governance and privacy tools. The data and compute remain within the customer's Snowflake environment, and that adheres to the strict regulations that you've set up and ensures robust security for sensitive information.
Okay, looks like our last 2 questions here. Could you elaborate on the use cases for the upcoming anomaly detection features in Q1 of 2025?
Yeah, the goal with anomaly detection is really around allowing businesses to more efficiently collect and manage data that is anomalous. Primarily, what we've seen is that defect data is scarce, and starting with an anomaly model can allow you to start to build and identify those defects and those defects that you may also not be aware of. So the goal really is to manage the defect data for better decision making and primarily process optimization. So you're not taking a year to collect that data every time the operator sees a defect or creating sort of known defect reels manually. You're able to collect and see in real time when the model predicts it's anomalous, and then you can verify if it actually is, and get to a faster, good set of data.
Excellent. Next question. Can we use the model for real-time live video streaming for detections and auto-labeling in our projects?
So today we offer the ability to work with live streams through our LandingEdge software. So you can incorporate an RTSP stream and see the results on that data. That data can be loaded back to LandingLens, and you can leverage those new predictions to continue to iterate on your model. We also work with, we have a helper library that works with pipelines that are video based. And so you can apply those results or see the predictions to specific frames within a video set. That would be how you would perform those types of tasks with LandingLens. So the inference API can be leveraged in real time, but you would have to set up that programmatic review so that it's looking at a set of or a specific frame rate, or the option to do that within LandingEdge. The other option would be to leverage VisionAgent to create an application to do that analysis. VisionAgent today works with 30-second video clips, and that will be optimized for the future. So hopefully that addresses your question.
Oh, two more questions and we can wrap it up. Next one, can you use this model to detect defects?
Yes. So depending on how you've defined what your model is sort of trained on, you can use the model to identify for defects. Today in VisionAgent, you can test sort of the open state-of-the-art models that are available to see if it's able to identify defects. I have seen situations where that's the case. You can even see for the example program that's here below. This is obviously missing a soda can. So this would be an opportunity for this particular case set to identify missing cans, which is a type of defect. But really dependent upon your visualization of your defect and how clear that defect is, VisionAgent might be able to use a available model that doesn't require fine tuning to perform the task. But if it's very particular and not more open source data friendly, then you may want to build a custom model in LandingLens that's fine tuned on the features of those defects.
Excellent. We've got just a couple more questions. People are really, really interested in the presentation. So let's go ahead and get these answered. The two-dimensional barcode on the screen, how to scan, what software may I use?
You should be able to leverage your phone to create an appointment, or you can just reach out to sales at LandingAI to schedule that consultation.
Okay, and the next question is, when can we expect any use case session specific to VisionAgent in the coming year?
I know we will continue to focus on developing this application, so I only expect that we'll have more webinars and more developer-friendly events for VisionAgent. So we'll definitely take that back to the marketing team and subscribe to the newsletter so that you're aware when we have them. I don't have specific dates on that as of yet.
Great. Our last question. What kind of tasks can be streamlined using the revamped LandingLens API, and Are there plans to expand API functionalities further?
Yeah, so the main tasks that I've seen is that customers have already developed applications within their business that leverage vision models. And so they're incorporating the pipelines to be embedded in those existing systems. And that is why the LandingLens API is super beneficial. So you can see when I pull up the API here, the endpoints are sort of all around the different ways you interface with the platform. But the goal is that the end user never is interfacing with ultimately LandingLens. They're interfacing with the existing system that's already been set up at their company. So that's primarily how the LandingLens API is leveraged. And then we'll be extending and adding more functionalities throughout the year next year. But there is a focus for the first quarter on some new features as well. Hopefully that answers the question.
And with that, we've come to the end of our session. Thank you, Erica, for a great presentation. We encourage everyone to sign up for LandingLens. It is free. Join our community. It is a very interactive community, and we are constantly answering questions and getting great questions. Become LandingLens certified, please. And again, just for housekeeping, we will send out the recording tomorrow with a couple of links to schedule calls with our reps. We look forward to learning more about use cases. Happy holidays. We're wishing everyone a happy 2025 and a safe and wonderful New Year's Eve.